This will begin the lecture for Chapter 6, and Chapter 6 deals with thermal energy. The first section deals with temperature and heat. Temperature. Use the words hot and cold to describe temperature. Something is hot when its temperature is high. When you heat water on a stove, its temperature increases. How are temperature and heat related? Matter and motion. The matter around you is made of tiny particles, atoms, and molecules. In all materials, these particles are in constant, random motion, moving in all directions at different speeds. The faster they move, the more kinetic energy they have. This figure shows that particles move faster in hot objects, the fire of a forge, than in cooler objects, a horseshoe, and a horseshoe game. The temperature of an object is a measure of the average kinetic energy of the particles in the object. As the temperature of an object increases, the average speed of the particles in random motion increases. In SI units, temperature is measured in kelvins. More commonly used temperature scale is, of course, Celsius scale. 1 Kelvin is the same as 1 degree Celsius. Thermal energy. If you let cold butter sit at room temperature for a while, it warms and becomes softer. Because the air in the room is at a higher temperature than the butter, the particles in air have more kinetic energy than butter particles. Collisions between the particles in the butter and the particles in the air transfer energy from the faster moving particles in air to the slower moving butter particles. Butter particles then move faster, and the temperature of the butter increases. The sum of the kinetic and potential energy of all the particles in an object is the thermal energy of the object. Because the kinetic energy of the butter particles increased as it warmed, the thermal energy of the butter increased. Thermal energy and temperature. When the temperature of an object increases, the average kinetic energy of the particles in the object increases. Because thermal energy is the total kinetic and potential energy of all the particles in an object, the thermal energy of the object increases when the average kinetic energy of its particles increase. Suppose you have a glass and a beaker of water that are at the same temperature. The beaker contains twice as much water as the glass. The water in both containers is at the same temperature, so the average kinetic energy of the water molecules is the same in both containers. There are twice as many water molecules in the beaker as there are in the glass. So the total kinetic energy of all the molecules is twice as large for the water in the beakers. As a result, the water in the beaker has twice as much thermal energy as the water in the glass does. If the temperature doesn't change, the thermal energy in an object increases if the mass of the object increases. Heat. Heat is thermal energy that flows from something at a higher temperature to something at a lower temperature. Heat is a form of energy, so it's measured in joules, same units that energy is measured in. Heat always flows from warmer to cooler materials. And I use the analogy that if mom yells at you for leaving the door open, saying you're going to let all the cold air in, it's not true. You're letting the warm air in the house out, in the winter, of course. Heat always goes or flows towards cold. Specific heat. As a substance absorbs heat, its temperature change depends on the nature of the substance, as well as the amount of heat that is added. The amount of heat that is needed to raise the temperature of 1 kilogram of some material by 1 degree Celsius is called the specific heat of the material. Specific heat is measured in joules per kilogram Kelvin. Water as a coolant. Compared with other common materials in the table below, water has the highest specific heat. And an easy analogy we can use is if we were to take say a spoon made of iron with a specific heat of 450 and a wooden spoon, and put them, say like on a burner on a stove, an electric burner, let's say, and for 5 minutes, and then I asked you which one would you rather touch. Well, hopefully you'll pick the wood, which has a much higher specific heat, which means that it would take longer to get up to that temperature than the iron, because the iron has a low specific heat because of the materials in it. It's going to warm up much faster, and it's going to release that heat a lot quicker. Specific heat of water is high because water molecules form strong bonds with each other. When heat is added, some of the added heat has to break some of these bonds before the molecules can start moving faster. Because water can absorb heat without a large change in temperature, it's useful as a coolant. A coolant is a substance that's used to absorb heat. Compared to other materials, the temperature of water will increase less. In metals, electrons can move freely. When heat is added, no strong bonds have to be broken before the electrons can start moving faster. Thermal energy of an object changes when heat flows into or out of the object. If Q is the change in thermal energy and C is specific heat, the change in thermal energy can be calculated from the following equation. The change in thermal energy measured in joules equals the mass of the object measured in kilograms times the change in temperature, degrees Celsius, times the specific heat. And the units of specific heat are joules per kilograms degree Celsius. So that Q equals M times the change in temperature, the final temperature, minus the initial temperature, times C. And I mentioned in class that you'll more often see this formula, that they'll be solving for the C more so than this Q. And that C is the specific heat. In this case, C, or specific heat, equals Q divided by M times T sub F minus T sub I. Specific heat of a material can be measured using a device called a calorimeter. In a calorimeter, a heated sample transfers heat to a known mass of water. The energy absorbed by the water can be calculated by measuring the water's temperature change. The thermal energy released by the sample equals the thermal energy absorbed by the water. This concludes the lecture for section 1. I'll run through these questions, and then your homework assignment following the lecture is to complete the section 1 online review, which can be found in your My Big Campus account. Question 1, how is temperature related to kinetic energy? Temperature is a measure of the average kinetic energy of the particles in an object or material. As temperature increases, the average speed of the particles increases. Question 2, how is temperature related to kinetic energy? I think we just answered that question. It should be how is thermal energy related to kinetic energy? Thermal energy is the sum of the kinetic and potential energy of all the particles in an object. Question 3, the amount of heat that is needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius is called the specific heat of the material. Letter C.